For starters, I've taken pictures of the part we're modeling from several different viewpoints. We can use these pictures inside Fusion 360 for reference. We'll go ahead and mark up this image with the measurements I've taken with a caliper. I'll be recording just the critical and semi-critical dimensions, and we'll use these reference photos to model the remaining features and dimensions inside Fusion. I'm going to call this the length of the part. I'm going to call this the width of the part, and that the height of the part. So the length of the part was almost right on the head, 900 thousandths. The width of the part was 905 thousandths. And the height was 590 thousandths. On the bottom side of the part, there's a little shelf, like a little recession. The encoder has a nut that affixes it to the face of the wheel, so you need to be able to clear that. That depression was about 140 thousandths, give or take. And the part also has a hole running up the center of it, so it can affix to the encoder post, if you will. The full depth of that hole was 460 thousandths. Looking at the bottom side of the part, we've got a wall going around the outside that was 70 thousandths. And we've got some clearance here. That's not too important. We can use the reference photo inside Fusion to make those indentations. So I'm not too worried about those. I am worried about this dimension because that's nearly a press fit dimension. Obviously the plastic will accommodate that fairly well, but we want to be pretty close on that. So the diameter of that circle is 235 thousandths. As you can see, it's got a little flat in it, otherwise it wouldn't turn the encoder too well, of course. The distance from the flat to the other side of that, the diameter of that hole, is 187 thousandths. So that should be all we need as far as dimensions, and then we can import these reference photos into Fusion 360 and start modeling. Alright, so let's start by creating a component. It'll be an internal component, name it whatever. We don't have any bodies to create the component from. We're just creating a blank component, so leave everything else as it is and leave activate checked, because we'll want to, first of all, it'd be the only component we're going to have in this design, and we definitely want it to be activated. You always want to work with activated components, because when the component is activated, your timeline fills up just for that component. If you have the entire design selected, and you're applying operations to different components, it becomes a huge mess because all the different operations are applied to different components within your design, and they're all in the same timeline. So it becomes a real big problem if you have multiple components. In this case, we'll just have the one component in this design, so it really wouldn't matter, I guess, but always good to practice a good clean workflow. So we've created the components. First thing we'll want to do is import one of our images in the form of a canvas. So the great thing about canvases is they can be calibrated to be scaled exactly the size of the component of the part you want to create. So probably best to start with a top view so we can get the gist of the solid created. Let's apply it to the ground plane, and because you can drag and scale it via this handle here, but it's really not going to matter. We're going to calibrate the canvas to known dimensions after we've imported it. I'm going to drop the opacity a little because it doesn't need to be super opaque. We don't need it to be we don't want it to be selectable. We just want it to be a reference image. We don't need it to be renderable because we won't be doing any rendering. And all of these manual dimensioning steps we can leave, because like I said, we're going to be calibrating it. So now that it's imported into our components, navigate down to it, right click on it. It's called top view. Right click on it and go to calibrate. Let's look at it straight on here. So what do we know about this? We know that from this, the front of it, we'll say, to the back of it was 900 thousandths of an inch. So I'm going to put points, calibration points on the very far right edge of the canvas and the very far left edge, which I've measured with the caliper, and it's almost on the head, 900 thousandths. So put those 2 points in, and it'll ask us, okay, how far is that? What is that dimension? We'll just call it 900 thousandths, or just 0.9. So there you go. We've got our canvas that is now to scale at 900 thousandths of an inch. Okay, so I want to see the origin here. So the origin will be important that it's in the center of our design, because we're going to sketch out half of this shape and then we're going to mirror it on the x-axis. So to sketch out the shape, obviously go to create sketch, put it on the ground plane, which is the same plane that we put the canvas on. We're going to start with some straight lines and start drawing out the shape of this canvas, the shape of the part. Okay. The first 2 lines are going to be obviously pretty easy to deal with. And you don't have to... This outside dimension is not critical. Of course, if the button's skewed a little, or it's 5 thousandths too wide, looking at the wheel, it's not really gonna matter that much. There is a try to get that. There's a ridge right there that you can see towards as you're looking at it, the top of the encoder, or the plate that the encoder attaches to. And obviously, if the button is too long in this direction, it's going to hit that. So we want to be pretty close with our dimensioning, but it doesn't have to be exact. I mean, we will get it pretty close. So we've got the first 2 lines created, straight lines, easy peasy. The next one will be a fit point spline. And with a fit point spline, you can select your starting point, maybe select 1 or 2 points along the curve. For here, we're just going to use 1. It's one big sweeping arc. So start it, put 1 maybe in the middle, and then a point at the end of that arc. See if I can get it to not snap. Okay, there we go. So let's select the selection tool, and we can go ahead and move the midpoint of this arc and any other points you'd like to kind of adjust it to fit the canvas. I mean, that's close. That's close enough. We're going to finish this off with a couple other straight lines. Boom. I'm going to extend this out into the center of the part. Oops. And I'm going to do another straight line from here and let them intersect. Now I'm going to use the trim tool to trim the parts of that sketch that we don't need. I'm going to fillet this inside corner here. And yeah, that looks pretty good. And then I'll go ahead and fillet the rest of the outside corners. There's really no hard edges. Really no hard edges on the outside of here. No sharp edges, I mean. So we can fillet that, fillet that. Fillet that, and I'm gonna leave. I've modeled this part before, so figured out that I don't really want to fillet that right now. So we can do that later once we have a solid part. So I've selected these 3 corners and applied that fillet. And now, so we've sketched half of the part here, half of that view, the bottom view of it. I'm going to also, let's go ahead and mirror that sketch right now. We'll select the mirror tool. The objects we want to mirror are, of course, the sketch we just created. You can select all the points of the sketch individually, or you can double-click on any part of a contiguous sketch segment to select the whole segment. So that's what I've done. I just double-clicked on one of the segments. So those are all selected. The mirror line, like I said earlier, we're going to use the x-axis. It's just convenient. It's right in the middle there. We could mirror off of a geometry feature on an existing body, an existing sketch, or the origin there. So let's just use the origin, the mirror line, select the x-axis, and boom. Now you can see here the sketch doesn't exactly line up. And that's mostly due to the fact that when I took the picture with my cell phone, I wasn't exactly 90 degrees to the part. And you'll get that. And like I said, these outside dimensions are not super critical. If they're super critical, then you'd want to go with a caliper. Go with a caliper and measure those and get them exact. Like I said, if they are critical dimensions. In this case, I'm just going to mirror it and we'll make do with it. It'll be pretty close. So say OK. And now you've got a complete sketch that we can extrude into a solid. Before I do that, though, I'm going to go back and edit that sketch. Oh, I'm still in the sketch. Okay. So there's another big geometry feature here, and it's the outcropping of the vertical part of the knob that you can actually grab with your hands. So let's do a center diameter circle starting on the origin, which again, this canvas just so happened to be right on the center of our origin, and this kind of worked out. You can grab a canvas and move it around and stretch it and skew it manually after you've calibrated it. But thankfully in this case we don't have to do that. So I'm just gonna get it close here. Boom. And let's see. Draw a line from here to here. Now you see when I'm touching this line to the edge of this circle, it'll reach a point where it hits the, like the tangent. It'll make the line tangential to the circle, and that'll constrain that line to the circle. So go ahead and do that. It's a good way to keep it clean is work with sketching constraints, and I'll go over that in another video. But for this video, we don't need to go too much further into it. I'm going to mirror that one line that I just created, and again mirror that off of the x-axis, and there we have that. We'll finish up this sketch by trimming the inside part of that circle there, and now we've got 2 individual parts of that sketch that we can extrude and make our make the solid body of our part and start working with solid bodies. So let's see, the middle section was 59 thousandths. So I'll go ahead and extrude that 59 thousandths. You can do it by dragging this handle or just type in the box 590 thousandths, not 59 thousandths. All right. And the outer shelf here, we're going to extrude that. And I'm hitting E for extrude. The hotkey for extrude is E. You could also use Q for press and pull. And that was 200 thousandths. So 0.2 inches. Boom. So okay. We've got a solid body there. Looking like a knob. All right. So next we're going to want to import the side view of the picture we took that was a side view of the knob. I'm going to go ahead and hide the body that we created. And I'm going to create something called an offset plane. So we can select one of these planes on the origin of this part, the origin of this component. We can right click it, say offset plane, move it out outside where the solid body would be, say just move it out an inch. On that plane we will insert the side view as a canvas. There we go. So I've selected side view.png, and then the face we'll apply it to is the offset plane we just created. Boom. Now, just like the top view, we're going to right click on the side view and calibrate it. And we know that that was what? Also about 900 thou. Okay. Yeah, 900 thou. So that dimension front to back here is the same dimension front to back here. So 900 thou, 900 thou. It's the same dimension, just from a different view. So we'll call it 900 thou. Boom. I'm going to show the body again so we can get it properly lined up, get the sketch lined up. It looks pretty close, actually. Looks pretty close. See how when we calibrated them both to 900 thousandths, they're basically exactly the same length here. That's exactly what we want. Okay, that looks pretty good. So now we can use that canvas to start chopping away at this solid that we've created. First thing we'll do is create a sketch. You can use a sketch to split the body and come up with this geometry here. So do a sketch, and we'll do a sketch on that construction plane where we put the canvas. And all we'll need here is just a single line sketch. Just put it wherever. Then we can select both edges of it, or both ends, and move them about. So yeah, that looks pretty good. Move them about so it matches the angle of the back of the knob or whatever. The back top of the knob matches that angle and that geometry there. All right, finish the sketch, and we will do a split body. So when you split a body, you can select sketch geometry. First, you'd have to select the body to split, and then you can select the splitting tool, which was that line we just created in that sketch. Pretty cut and dry there. As you can see, it's going to split our knob and knock off that back bit of it, whatever you want to call it. So boom. Next thing we'll want to do is go into selection priority and select body. Select that part that we just sliced off and right click and remove it. There we go. Now the back edge here, the back face, we could do a split with a sketch as well, but we could also draft it. So I prefer to actually work with the modify features when they apply. I guess you could do You could do a chamfer of that back edge, or the one we just split. You could chamfer that if you got the angle right, but chamfers generally, it's easier for me to do a 45 degree chamfer than, whatever this is, 30 degrees or whatever. 45 is the default. So I'm going to go ahead and draft this. This face right here, we're going to draft it, which is basically tilting it in relation to another face or feature. So it's kind of weird. You want to select a face that we can reference off of, which is the whoops. Select a face we can reference off of, so the bottom of the part, and then the face we want to move, like I said, is this face right here. So you've got a little handle you can pull and angle that back face. 10 degrees doesn't look to be exactly right, so let's make it maybe 9 degrees. Yeah, it looks good. Okay. It's starting to come together. Let's see, what should we do next? I think I'm going to go through and fillet all these edges. Make them look a little prettier. So, hotkey for fillet is F, and then just select all the edges you want to fillet. I think, let's see, whoops, I did not mean that. Okay. Maybe do 5/1000 fillet. Yeah, that looks really good. All right, we'll fillet the rest of them. Five thousandths. Yeah, that's looking pretty good. Let's see, what do we want to do next? We'll have to do the bottom of it. So let's look at the bottom face. Let's go ahead and hide that first sketch we created so we don't have to see that anymore. We can hide the other sketch we created and hide both of the other canvases we imported. So we're going to import another canvas, which is the bottom view of the part. We can either, since the bottom of the part and the ground plane, the origin is in the exact same spot, we can import the canvas to either. I'm just going to import it to the ground plane of the origin. Rotate it exactly where we need it to go. We don't need to do anything more with it because we're going to calibrate it like the other one, like the other ones. And just the same, we know this dimension, front to back. So we're going to select both of those points, front and back points. And like the other two sketches, 900 thousandths. So it's calibrated, it's the right size, it's just not in the right spot. So right click on it, go to edit canvas and move it, close enough, get it close. Sure, that's good. So there's a couple features on the bottom of this part. One feature is the recession that goes, it is the entire bottom of the part is recessed, as you can see. And it's recessed so it can make room for the nut that holds the encoder in place. Yeah, right there. So that's critical that it's there. It's not critical that, not critical within a couple thousandths of an inch, but it's critical that we have that recession there. One good way to do this, we're going to create a sketch. The sketch we're going to put on the bottom face of the part. And what we can do to, we could go ahead and sketch the entire perimeter of the part, but since it already exists, obviously the part is there, the dimensions exist, we can hit P to project sketch and select the face, the bottom face of that part, and say OK. So now we've got a sketch we've got sketch dimensions on this sketch we just created that are exactly the same size as and dimensions as the bottom side of this part. So you can see sketch projected sketches show up in purple. So you can see all of them we've got there. Next, I'll do a offset of that sketch. Let's select it. Select offset, select a part of the sketch. And you can see what's going on here. Let's shrink that down. I think 70 thousandths was what we decided that wall size was. Negative 70 thousandths. We'll have to, yeah, there we go. Perfect. All right, so that's looking pretty good. The only other critical, the real critical dimension of this entire part is the hole in the bottom of it where it slides onto the encoder post. So that's what we'll do now. And that was 235 thousandths. Depending on if you're gonna 3D print this or machine a mold, or whether it's 3D printing with FDM or 3D printing with resin. I've got a resin printer. You're gonna have to do some. You probably have to print it a couple of times until you get your settings right. You might have to come back and adjust this dimension. It might have to be tighter. It might have to be 230 thousandths, or it might be too tight to fit onto the part. That's just something you have to work out and keep tabs on when you're moving parts from Fusion to your 3D printer. And different settings in your 3D printer are going to determine, if you can make it exactly, down to the thousandth, make it exactly as tight as you want, or you have to, make it a tighter tolerance in Fusion so that your 3D printed part really fits properly per your application. We can go over that in another video. We're just going to say your 3D printer can mimic this part exactly down to the thousandth of an inch. Perfect. So we'll make it exactly what I measured it to be with a caliper, 235 thousandths. As you can see, it's also got that flat in there. So we're going to need to know that flat, the center of that flat is 187 thousandths from the far edge of the circle. So what we can do, instead of, we've done all construction or all actual sketch lines so far, we can do a construction line, which is a dashed line. We can run it from the far edge of the circle through the center of the circle over to the center of this flat. And I'll manually put in that dimension, 187 thousandths, run it through the center of that circle. That'll be pretty close. Okay. That looks good. Turn off construction line and sketch an actual line, 90 degrees. And you can see this sketch is constrained. You can see it's 90 degrees from the construction line, from that little right angle there. So run that out to the side of the circle and run that the other direction out to the circle. We can trim this construction line, and we can trim this outside part of the circle there. What else? We'll do a center diameter circle in the center of the part and run it out to here, so we can get those relief indentations or whatever. All right. Go ahead and trim away the parts of the sketch we don't need again. Whoops. That looks good. All right, that looks good. So I'm going to go ahead and hit E to extrude. We're going to extrude this bottom guy, the center post hole first, whatever you want to call it, and that had to be 460 thousandths deep from the bottom edge of the part. So negative 460 thousandths. Makes sense. Okay. And then this little shelf or depression, recession, whatever, that had to be 140 thousandths, 0.14 inches. So minus 0.14 inches. All right, let's hide that canvas, hide that sketch. That all looks pretty good. That looks like the knob that we were trying to create. Okay. Now you can go ahead and print it, or we can add the finishing touches to it. I want to go ahead and bring back that top view. And oh, actually, you know what? No, I remember the top part of it had an angle to it. This face right here, that it had an angle to it. So let's go ahead and take care of that. Let me hide that body. Select priority, select by face. We're going to create, come on, create an offset plane here. Pick it out. Insert a canvas to that plane. Let's do front view. Great. Calibrate that canvas. I think we decided the width of the part was 900, yeah, 905 thousandths. What's going on here? Select both sides, close as we can get them. 905 thousandths, boom. Let's show the body again. Move that canvas. Oh, I mean, that's close. Close enough. So we want to mimic this. We want to model in the angle that the top part of the knob is set off at. So we can use a draft again. Draft from this flat surface as our reference surface, and the face we want to draft. Oh, I might have to, yeah, select face. Okay, face you want to draft is this guy. Oh, that's, what have I done? What have I done here? You know what? Let me go back and undo these fillets. I think we're having a problem there. Suppress those features. All right, let's try to do this draft again. Much better. I don't know what was going on there. That's maybe a bug. I'm not sure. All right, so we've selected a reference face. The face we want to draft is selected as well. You can see, makes sense. Let's go ahead and draft it close enough. That looks pretty good. Maybe it's more like 10.5 degrees than 11. Great. All right, now let's see if we can unsuppress those fillets. Yeah, that must be a bug. That's weird. That's weird. Okay, so anyway, looking good. We've got the angle of the top of it. Boom. All right, the last remaining feature will be these little yellow indentations that are painted. Let's go ahead and create a construction plane. We're going to emboss those. We're not going to actually sketch on these faces. We'll do a construction plane and sketch on that construction plane. So what do I want to do? I want to hide that body, select this ground plane, do an offset of that up above the part. Sure. Bring the part back. Okay, let's do a sketch on that construction plane. We're going to sketch out this bottom guy, and then we're going to mirror it up top, and then we'll sketch out the bottom half of this guy and mirror it, or just, you know, sketch it all and not mirror it. Okay. So let's do a fit point spline, because there's not a lot of straight lines in this guy. Do a fit point spline. That's pretty close. Let's do some cleanup of that curve there. That looks really good. Yep, that looks good. So we've done the outside curvature of it. We can then do an offset of that line and put it there. Then we can do a couple of 2-point circles here and here. That looks pretty good. This looks pretty sharp here. I wonder if we can fillet that. Maybe not so much. Maybe not so much. Okay, that's fine. That's pretty close. All right, so we're going to mirror that off of the x-axis, and that's good. Now let's mirror this top guy. Sorry, we didn't mirror it. We just created it without mirroring. What's going on with this fillet? All right, so we've got a rectangle there. We'll fillet all the edges of that. Okay. So next step we'll want to do is finish that sketch, and then we want to emboss these sketches onto our physical part. So let's modify emboss. Or is it create emboss? I always forget to find it. I don't use it that often. Okay. Emboss these guys. Select both those profiles. The face we'll want to emboss those onto is... What is going on here? There we go. I had tangent chain selected, so it selected basically every face attached to the face I selected. Not helpful. Not helpful in this circumstance anyway. I didn't measure this. I don't think this is set too deep. I think 5 thousandths is probably about right. Now, when we emboss the one up top, since we're embossing over 2 separate faces, we should need that tangent chain selected. So we'll do another emboss, select that profile, and the faces. Maybe I don't understand how tangent chain works exactly. Emboss is a very new feature. It came out like 2 weeks ago, so I have not dealt with it that much. Anyway, we can do 2 separate embosses here. Oops. All right, so 5 thousandths, negative 5 thousandths. And let's do another emboss. Same sketch, different face. Boom. That looks like it also went 5 thousandths. That looks good. All right, finish up, do some fillets, soften up some edges here. Might have to be one. Yeah, that looks good. I try not to leave any right angles. If I'm going to be, you know, rendering it, right angles look really awful when being rendered. If you need a absolutely sharp right angle in your part, it's whatever. It's cool. But that is looking pretty good. I think the last things we can do is we can apply some textures to it and maybe do a quick render, and we'll export it for 3D printing. Excuse me. So hit A to bring up appearance. Let's search for, I think there's a rough plastic texture that'll look really good. I think it's called random. Plastic texture random. That'll look good. Edit that texture, edit the scale of it. Well, you can't see that. Gotta move this over. Edit the scale and bring it down. Oh, it's pretty fine random texture there. That'll look good. So that'll do it for the black parts. Well, the entire thing is black, of course. And then let's select faces and apply some sort of yellow. Let's see what they have for yellow. Plastic matte yellow. Plastic glossy yellow. How about that? Apply it to all faces that should be yellow. For some reason I can't apply to this face here. Yeah, there we go. Boom. Hide that sketch. Close appearance. Hide the origin. Hide everything we don't need. Hide all our construction planes. Canvases. Boom. Looks good. Looks real good. Let's go ahead and render it real quick. Just a super quick render. Looks pretty decent. Looks pretty decent. Maybe I'll 3D print it and show you guys the final result. But yeah, that looks pretty good. All right, so now that we've created our part, it's all dimensionally pretty accurate. Let's go ahead and export it for 3D printing. I think that's in Tools now. Yeah, they redid this whole interface here. So Tools, Make, 3D Print, Refinement High. We can send it directly to a 3D printing utility. I just prefer to export it as an STL. Whatever. Select the component as a whole and hit OK. Yeah, so I did this design before I did this video. But export it, knob.stl, sure. There we go. I think we're done. So I'll go ahead and put a link to the STL file and this Fusion 360 project file so you can check it out on your own. You can load it into Fusion 360 and have it, export it, 3D print it if you want. But I hope this was useful, and think next, or at least soon, I don't know about next, but I'll be doing a series of videos on how I created my rig over here, formula rig. Yep. So, anyway, have a good one.